Good evening, and welcome to the Forum, Columbia's newest resource and the gateway to Columbia's new Manhattanville campus. I'm Mary McGee. I'm the Executive Director of the Forum, and it is our great pleasure to join with the Zuckerman Institute tonight in hosting this celebration of mind and soul through the medium of jazz. This is our first musical event in this auditorium, so this is being inaugurated tonight, and indeed our very first musical event at the Forum, because we are just in our first year, so we are experimenting, so we are thrilled to have this event here tonight. Before the program begins, for those of you that may be new to this facility, just a few of the housekeeping rules to go over. As you know, there is no food or drink in the auditorium except for water in covered containers. If we ask that you enjoy your food and drink outside in the foyer, there's a live feed to the monitors out there if you need to step outside. Note that there's 4 exits from the auditorium at the bottom and top of each of the staircases. If you find that you need to leave before tonight's event is over, please consider going through the upper auditorium exits. The gendered restrooms are here on the 2nd floor. Gender neutral restrooms are on the 3rd floor and down in the concourse level. Do be aware that tonight's event is being live streamed, just to think about that. And lastly, so that we can all fully engage with and enjoy tonight's performance, take a moment to locate and then silence your cell phones and any other electronic devices you brought with you tonight. And now, to introduce tonight's program, Dr. Rui Costa, who's the Associate Director of the Zuckerman Institute.
Hi, everyone. It's great to be here, to see so many familiar faces and some new ones. Welcome to the Mort Zuckerman Mind-Brain Behavior Institute Beyond the Brain interdisciplinary series, which is kindly sponsored by the Dana Foundation. So tonight we're going to have a special event entitled Jazz and the Neuroscience of Decision Making, a celebration of mind and soul, where Mike Shadlen, who's a professor and neuroscientist at the Zuckerman Institute, Chris Washburne, who's the director of Louis Armstrong Jazz Performance Program, and Helen, who is a pianist and composer and the first jazz artist in residence at the Zuckerman Institute, sponsored by Alan Kanzer, are going to talk about emerging concepts in neuroscience and begin to expose from the biology of deliberation and improvisation to decision making, to timing, everything that relates the brain and music. They'll show or allude to recordings from brain cells and brain activity, and also we'll have, as you see, live music here in what we hope to be really an interactive dialogue between jazz and neuroscience. The goal of this Manhattanville campus of Columbia University and of this lecture series is really to promote integration of knowledge across vaster, wider disciplines than have interacted before. It's an experiment. It's an open campus in the middle of Harlem. And so we hope to gather here many creative minds and create an open forum that also includes you in research, in study, and in creating new ways of thinking about the brain and about art. So tonight in this event, we hope to bridge the areas of neuroscience, creativity, and music. And I would like you to join me in welcoming Mike, Chris, Helen, and the band to this event tonight.
Thank you, Rui. Thank you all for coming here. Let's have some fun. We're tonight's an evening where we're going to try and mix science and music. And I mean, what could be? Oh yeah, we're up. That's great. What could be more fulfilling, I think, at least to me, to mix these two great parts of our life in the center of it all for neuroscience, the JLG, and for jazz, Harlem. So it's a great pleasure, of course, to share the stage with these amazing musicians, and you're going to get to know them in a moment. Let me first begin by introducing a little bit about what the night's going to be like. It's going to be mainly improvised, of course, the music, but that will also be true for some of the science. And that means we can just take this whatever in any direction that interests you. So let me tell you why we care about decision making. There's lots of reasons to care about decision making. I'm going to claim that when we make a decision, in this case a pretty trivial one, which path to take, we're really thinking about the essence of what a thought is in the brain. Decision making invites us to think about cognition writ large. Like, are we seeing cognition? Yes, a window on cognition. And I'm going to argue in a little bit that it's also, we like to think, a window on what goes wrong in cognition, disorders of cognition, be they psychiatric or neurological, and that's what we're studying next door at the Mind-Brain Behavior Institute. Now, why cognition? Because when we think about decision making, we think about, no, I need my glasses, that's my problem. All right. These are my artsy glasses. I hope you don't mind. Violating symmetry. We're going to violate the rules tonight. The decision making invites us to think about evaluation of options, taking evidence from the world, prospecting, meaning thinking about ourselves in the future. Will we be more satisfied on the left path or the right path? And strategizing. How far do I want to go before I'm willing to turn back? It also invites us to think about foraging, looking for things with a purpose, exploring, not capriciously, with some kind of a goal in mind. And that, I think, brings us to creativity and improvisation, because we see both the rudiments of higher brain function and thought in decision-making, in foraging, in exploration, and of course, that's what we do when we express ourselves to each other in language, when we tell stories, and also when we improvise with our instruments. So I'm going to be really quick so we can just get to a little bit of music, but I want to seed a thought that's going to permeate the evening. So I want to argue that, I want to share with you an insight, and that is that thought can be thought of as directed exploration. And unlike what the computer scientists tell us, the job of the brain is not to understand information, not to process information and put a label on it. The job of the brain is to interrogate. And if we think about the part of the brains that interrogate the world and some kind of purpose in mind, it's the bigger parts of the brain, the newer parts of the brain, and the one that interests me the most is called the parietal cortex, the parietal lobe. Now, if you are unlucky, I hope this never happens to any of you, and you were to lose part of the parietal lobe, your problem would be through damage, through a stroke, through a tumor, something like that, something horrible. But you may well recover, so I don't want anyone in this room to lose hope should anything negative happen to them. But the symptoms that you might have, especially if you lost the right parietal lobe, you're looking at the left side of the brain, so you can't see the right parietal lobe. What would happen is you might neglect the left side of your body, the left side of the world, and you wouldn't even necessarily be aware that you are sick. We call that anosognosia, nausea being the Greek word for knowledge. So it so happens that if you were asked to draw a clock or a face, you might leave out parts of the left side. If you were asked to copy a clock or a face, let's see if I can get this to work. If you're asked to copy this clock or a house or a flower, again, you might leave out parts of the left side. So knowledge is about producing, and knowledge is also about how we interrogate the world in this case, the meaning of the left side. And by the way, if you had a hole in your visual cortex and you couldn't see the left side of the world, you would complain. I'm a neurologist, and you would say, hey, Mike, look, I can't see. But if you lose the right parietal lobe and you are not able to make sense of the left side of the world, you're not aware that there's even a problem because your brain doesn't interrogate the world. So I want you to think about knowledge, gnosis, states of thought as being answers to interrogation, question and answer. And if you don't believe me, just look at this picture, and something's changing every other frame. And raise your hand when you see the thing that is changing every other frame. There's like 5 people with their hands up. Oh well, you're cheating because you know this. Okay. Well, I'll give you a hint now. You would not want to get on this airplane if this thing was really missing, okay? All right, so everyone see the engine? There it is. Okay, now that engine was screaming in your visual cortex, okay? It was represented in the brain, but you didn't notice it, okay? And you didn't notice it because you are not interrogating that part of the scene. And the reason why is because those flashes invite your brain to interrogate all over this scene, which is a pretty complicated scene with all these people going off to whatever they're going to go do. And so we call this change blindness, but I think a better term for it is change distraction. Now, the idea of interrogation comes up in vision. I'm going to show you some artwork, which is really just optical illusions. So this picture, does it look like it's moving in all kinds of complicated ways? And you can have a sense that it's as if it's flowing and flowing and flowing, right? Well, this movie is just a 4-frame film. If you look at this spot here, you'll notice it's the same little stripe that's appearing over and over and over again. Tap, 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 tap. That's about the rhythm of that repetition. You see that? Here's another spot that might be easier. See those stripes? They're just always there. Okay? So nothing's really actually moving all along, but your brain was tricked, because I tricked it, into seeing a little bits of motion and thinking there ought to be something nearby. So when there is something nearby, you tend to complete that, and the answer to your question was in the affirmative, and we perceive that as motion. Okay? I'll stop it. You'll get a wicked after effect. Everyone get that? Woo! Okay. All right, I'm going to just show you a couple more illusions before we go. So here's one I call the growing baby illusion. That was actually my daughter 30-something years ago. I had her when I was 8, I want to say. Okay, so, and here's the one we call the changing baby illusion. Now, obviously, this one's not going anywhere. Now you know it's a 4-frame film. It just keeps repeating, but you do see expansion on your left, and you see the rotation. Okay? One more, just for the hell of it. Look at this spot. Look at this spot right here. It wiggles every now and then. But while you're looking at this spot, there are little wheels going. And while you look at that spot, try to look where my arrow is. And are the wheels moving clockwise or counterclockwise? Okay, now do me a favor. Look into this one. It's still going counterclockwise, right? Okay, now look into this one. It was never going counterclockwise. Okay, so why does that work? That works because these little elements are teasing your brain. They're kind of saying, hey, there ought to be something in the counterclockwise direction. That's true of all these little elements. But when this little one ratchets around in the clockwise direction, this little piece of light and dark pops into the zone that says, oh, that's confirmation of the prediction. And we see that as counterclockwise rotation. Okay? So the brain does question and answer. So perception involves directed interrogation, not just information processing. And it entertains prediction and resolution of predictions. And as the famous saxophonist Dave Lieben said, this has relation to art, because art is all about tension and release. And as he goes on to say, that's where the artist lives, between the two, or at times submerged in either. I think that's a really deep thought. And I want you to think about that. Thought as directed exploration. Information processing is question and answer. Now already, for anyone who is an enthusiast of classical or jazz music, that question and answer is one of those motifs that people use. So what we'd like to do is I'd like to bring Chris Washburne and the band out now, and we're going to play a tune, and we'll talk a little bit more about jazz. And as we play this tune, I want you to do your own question and answer, and listen as an interrogator of the music.
Hello, everyone. Hello, everyone. I'd like to take a moment to just introduce the fabulous musicians we have up on stage. Some very, very important jazz musicians in the New York scene, very busy and in demand. You're in for a real treat. Please welcome Charles Gould on the drums. Ugana Okegwo on the bass. Jason Marshall on the saxophone. And many of you are familiar, as she's our first inaugural artist in residence, jazz musician in residence, at the MBBI, the fabulous Helen Sung. And then, of course, the hippest neurologist on the entire planet. Do you know what HIP stands for? What does it mean in jazz talk? It stands for highly intelligent people. And since you're all here today, you're part of the hip crowd. Mike Shadlen on guitar. Thank you for listening to our interrogations and our explorations. It's fascinating for me and such an honor to be here to share this music with you and listen to all of the wonderful ideas and the illusions that were just presented, because it speaks very closely to what we do as we make a living and what we do with our art form. And I just want to take just a couple of minutes to talk about what jazz is, or what people have talked about jazz being. And I like to turn to the founding fathers and mothers of this music and get inspiration from them. And I think one of the most inspirational definitions that I found, and I think that also resonates a lot with what Mike was talking about, was the definition that Sidney Bechet gives us. Sidney Bechet was a clarinetist from New Orleans and one of the people that played with Louis Armstrong and really was foundational in establishing what became known as jazz and the practice of this music. And when he was asked about the music, he said, it's the sound of freedom. It's the freedom that the emancipated slaves found in their lives, and they had to make sense of that newfound freedom. They had to imagine new possibilities, and they had to transform ugliness into beauty. They had to take the scant materials at hand and transform them in some way and reimagine their lives. It took resilience, and it took virtuosic adaptability. And so what for Sidney Bechet is every time jazz musicians play, they sound out that freedom, and that freedom is at the heart of what we do. And then if we also think about what a more modern-day composer and jazz artist has talked about, one of the most famous jazz musicians alive today, the saxophonist Wayne Shorter, he was asked what jazz means, and he had this simple definition. He says, it means I dare you. And what's kind of cool about both of these definitions is that they're not treating jazz as an object or as a noun, but they're treating jazz as a verb, as an action, as a way of being, as a philosophy of life, as a way of navigating life. And so we can kind of step back and think about the dare and also the freedom that's there. And so at the heart of this music is improvisation, meaning spontaneous creativity. And why is that? Well, it was vitally important in order for when art forms start to emerge out of the aftermath of emancipation, that there was a paying tribute to those resilient founders of African American culture and reimagining what it could be. And that resilience and the amazing drive to survive. And how was that? By being able to adapt and adapt spontaneously to new circumstances. And so as jazz emerges as an art form, that's at the center, spontaneous creativity right before your very eyes. In other words, when jazz musicians get together, it's not like we've been spending hours practicing together and rehearsing for you. As a matter of fact, this conglomeration of musicians has never performed on stage before until just now. We've played with each other sometimes in other groups, but not in this configuration. And we've never played that song for you. That was the rehearsal, that was the dress rehearsal, and that was the final performance that you heard. Thank you for that applause, but actually, we're just doing what you do daily. But we turn it into an art form, and that in the sense of improvisation. We all improvise. We improvise every single day of our lives, often. I'll prove it. You're all alive. If you didn't improvise, you'd be dead. You had to cross 125th Street or Broadway to get here, right? And as you came across that street, you looked one way and it was clear. You looked the other way and there was a taxi coming right for you. What did you do? You improvised, you stepped back, therefore you're alive. And this is the way that we navigate our lives. That's why there's so many human beings on this planet, because we're such highly adaptive creatures. Jazz musicians just take those fundamental resources that we all possess and try and make them into an art form. But I mean, let's face it, who are the greatest improvisers in the entire world? Who are they? It's not jazz musicians, we're like 7th on the list. Scientists, 6. Children, exactly, children. And what age? 2. Definitely the 2-year-olds, they got it nailed. You put a 2-year-old in an empty room with a box, and what happens? Within 30 seconds, that box gets transformed into a rocket ship, a castle, a boat, a pet horse, all sorts of things. And they're amazing. And I believe all of you were 2 at one point in your lives. Correct? So you are amazing improvisers. And then something really tragic happened to all of you, including me. Preschool. Because as soon as you got into preschool, they started telling you all these rules and that you had to do it this way and not that way. And then, of course, a lot of you are really overeducated, like myself, and so we spent years and years of being damaged in one way or another by the educational system that has trying to figure out what to do about improvisation. But the problem with that is that that's one of the most amazing skills that we all possess. And you're absolutely right saying scientists, the most amazing scientists, the ones that are sitting here, are incredible improvisers. They have to be, to come up with new ideas and kind of think things through. As a matter of fact, what did we just do for you? What would you say that we just did? We played for you. But this is how we make a living. We didn't work for you, but we played for you. If you think about that, jazz musicians are tapped into our inner 2-year-old selves. Because we don't have a place of employment, we have a place of employment. And so I think this is one of the great lessons that jazz has to offer anybody, is like, what would it be like tomorrow when you go to work, you actually go to play instead? And I'll tell you, the most successful people in this world, they go to play, because it's a lot more fun than work, and we reach our fullest potential. So what does that have to do with neurosciences?
Whoa. All right. We're going to have some fun. We can go in a lot of places. I want to tell you something personal about childhood, if you don't mind. When I was a little older than 2, I got interested in the mind and the brain. And I would be at parties, and I would talk about crazy ideas about art, music, what made it nice, and how we interact, and why we love, and all that. People thought it was kind of cool, because there was a neuroscience thing about it, you know? I didn't know what the word neuroscience was. And then I grew up, and now I do neuroscience for a living, and everyone thinks I'm boring, because it's always just shop talk. But more seriously, here's the topics that I want to talk to you about. Because I want everyone to chime in when you have an idea that you want to share. And by all means, you can raise your hand and ask a question when you want. We'll have a more formal Q&A later, but you know, interrupt wherever you feel it. So I already made the case that thought itself should be viewed as a directed kind of exploration, playing, as Chris put it. And so that we can think about the metaphor of interrogation as opposed to processing. Then we're going to talk about time, because the essence of jazz is about time, and I'm going to argue the essence of cognition is about time. And I'm going to try to make the case that time really holds for us the archetype of arts in general, or the aesthetic. And then a little later, maybe we'll talk about decisions, which we kind of have to since it's on the billing. But so somehow or another, you got to remind me if I forget. And maybe even if we go far enough, we'll talk about communication and consciousness. All right. Now, I already told you that when we study the brain as scientists, we're studying it for a reason. I mean, there's no one-size-fits-all here. There's lots of reasons to be interested in the brain. But we study the brain, I do anyway, and I think I can speak for just about everyone at Mind-Brain Behavior Institute in saying that we're all very interested, or really Columbia neuroscience community, I should really say as a whole, is that we're all interested in ultimately helping people with problems with their brains. And so to do that, we do research, and we do research on animals and humans, and with mathematicians and theorists to try and make sense of things, and it's a big team game. And ultimately, we need to understand those things at all kinds of levels. If you ask me, we need to understand things at almost a philosophical level, but then we have to break things down to get to molecules and circuits and connections, because I think that's the way we're going to fix brains of people that have problems with their brains, be it from stroke or schizophrenia or depression or autism. Now, I showed you this slide a moment ago about the parietal cortex, so now I want to take you on a deep dive inside the brain, down to the very fine level of you know, here's an MRI, and put a little needle in there that's the size of a red blood cell where the metal is exposed, and put it right close to one neuron in the brain, in the parietal cortex, cortex being the outer part of the brain, the evolutionarily newer parts of the brain. And these cells have this capacity to do something over prolonged timescales. That is the, I think, the emergence of cognition. We'll get there. Okay, so here's a task. All right, you could do this. If I ask you to make an eye movement, not yet though, but make it to this briefly flashed red spot. Remember where it was. Okay, now go make your eye movement. All right? Now we're going to imagine, not have to imagine, I'm going to show you a movie of an animal doing the same exact thing, but this animal has a small microelectrode in the brain so we can record the electrical activity of the cell. Now, one thing I need to tell you is that those of us who work with animals care a great deal about them, and it's very important to realize that the brain itself has no pain receptors. So in neurosurgery, if you're unlucky enough to have it, the drilling through the head and all that, you want to have that done under anesthesia. But after that, when there's an electrode in your head, maybe to make sure that the surgeon doesn't cut out the part of your brain that controls speech, you don't feel that, okay? And the same is true for the animals in our experiments. So now I'm going to play you a sound, the electrical sounds of a neuron in the brain that has what we call spatially selective persistent activity. So check this out. I mean, you're going to see the eye movements like yours, but you're going to see this of the monkey that was doing this task. You're going to see this in yellow. Here we go. All right. So what you heard were little clicks of sound. Now, the brain doesn't make sound, obviously, but the brain has electrical activity, and we can amplify the electrical activity, and you can hear it as a bunch of clicks. Okay, so I've rendered it here for you in, you did see that? Yeah, I've rendered it for you with these little tick marks, and each one of those tick marks is the time of this little, we call an action potential or a spike, little electrical discharge, and this is the way the cells in your brain communicate. They make a little burst of electrical activity, that gets passed down, and ultimately it leads to a chemical being released, and the next neuron gets to know what the first neuron was talking about. This neuron was talking about this place in space, and in particular, for over the course of a second and a half or so, or 2 seconds, it held on to that. That's what this elevated activity is between the onset and offset of the red spot and the instruction to make the eye movement. And we think that this persistent kind of activity, which emerged in evolution in these higher parts of the brain, that this holds the seeds of cognition, because it confers a kind of freedom from immediacy. If you think about it, all of the mental things you do depend on having this freedom, not to be beholden immediately to changes in the world or the real-time needs to control your body. That's a real-time engineering problem. It's that escape from that kind of reflex-like behavior that led to cognition. Now, these neurons are spatially selective. As you can see, when the eye movement was to this target, there was no persistent activity. So, as someone in the lab, we will often exploit the properties of these neurons and try to understand, well, maybe we can understand how we make decisions. Maybe we have to choose between here and here. And if we were to choose between here and here, maybe these types of neurons would tell us, oh, we were more inclined to choose here than here. So that's the kind of thing that we do in the lab to try to understand at a very refined level, the level of single cells, how it is that the brain does things like make decisions. Well, I told you I was going to tell you about time, so I'm going to tell you a quick story about time. Here's the easiest experiment we've ever done in the lab. You'll get to do it. All right, you look at this red spot, you wait, and you wait until that red spot dims, and then you make an eye movement to the green spot. Okay, you wait and wait and wait. Oh, it happened now. Oops, okay, so you make the eye movement. Then, okay, if you're in the animal, you get a reward. Now, here's what we do. We play games with time. We put the animal in a room where the times are random, and sometimes they happen early and sometimes they happen late. So I want you to look at this graph and realize that what it's trying to tell you is that is that the waiting time was never 1 second. It was very often a half a second. It was also very often 2 seconds. That's what I mean by two modes, okay? Two kinds of times, two bumps. Now, I'm going to show you just one trial from this experiment. And in this one trial from this one neuron, this random neuron in the brain, you're going to be able to understand how the brain computes time. I'm going to pick a trial where the animal had to wait just over 2 seconds. Of course, sometimes only had to wait half a second, right? But this time he's going to have to wait 2 seconds. And I want you to understand what the meaning of anticipation is. I'm preparing you to interpret this result. Anticipation looks like this dashed function. It says, okay, as we're waiting and a half a second is coming, I'm expecting this thing is going to happen. But if it didn't happen, it's not going to happen here. And then we keep waiting. Oh, it's very likely to happen around 2 seconds. So we can imagine that what anticipation is, in this case, is triphasic. It is a rise, a fall, and then a rise again. All right? So now I'm going to play you a neuron, recorded in real time, and you can listen to this neuron, and I want you to see if you can detect that there was a rise, a fall, and a rise again in the activity. Okay? The eye position will be shown to you in yellow, but that's not observed by the animal. Do you go up, down, up? Should I do it again? All right. Okay, up, down, up. Okay, so now that's to me it was an accidental observation. It had to do with changing a random number generator in a computer program, and suddenly I heard the neurons responding differently. But I think it gives us some really deep insight about that interrogation point. It says that time in the brain is not like a clock. Tick, 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 put a label on each of those ticks, 1 second, 2 seconds, 3 seconds. It's more about what I expect to do, what kinds of things are happening in the structure of my world. I'm expecting something now, whoops, not yet. Now I'm expecting it again, that kind of a thing. So let's play one last game, and this is a group thing, and it involves some clapping. It won't be the first time, won't be the last time you clap tonight. I hope. All right, so here we're gonna do something, a game called Ready, Set, Go. And you're going to do, I'll give you a spot where it says ready, and then another spot where it says set. You time that, but you try to time your clap to match that interval. So if I go ready, set, okay? All right, so let's do it together. You ready? You get ready. You got to drop your cell phones. Here we go. Not bad. Do they have a job? Can they play? Okay. Oh, okay, I won't do it. That's what they probably want me to stop playing too. Okay, so here we go. Next one. Whoa, 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 whoa. I've done this a lot of times. That was the worst ever. Okay. Okay, so I'm giving you another shot at that one. Remember, you got to wait for the set. Ready, set, go. Or maybe some of you from England. Ready, steady, go. Okay, here we go. Jesus. Okay. Okay, so spot, and then your clap is the third spot. Okay? Let's do this one more time.
You know that thing I said about this being a hip crowd? I'm questioning that right now.
I think it's late or something, you know, or I'm just not making any sense. Here we go. Here we go. Okay. All right. Okay. And one last one now, and you better now concentrate on this one. Wow, you got it, Helen. Okay. Now, really, that last one, normally the way this works is people are great at the second one, and then they're trash at the last one. And the reason why is because you weren't expecting it to go fast. So your brain is timing and anticipating, and you You would have been slow. Most of you were probably slow, especially those of you who did well on the second one. Did you find that you were a little slow on the last one? Some nods, thank God. Okay. So now let me try to make a more serious point here. Okay, time is the key to thought, okay? I kind of told you why I think that's true. It's because it involves freedom from immediacy. It involves us to be able to entertain possibilities and not actually act on them in the moment. Okay, now obviously time involves playing music. It involves making beats and, drumming, playing sports, dancing, inferring causality. If something hit, bang, there's the noise. Maybe the thing that fell caused the noise, and so forth. Mimicry, you can name it. Time is part of everything. I'm going to have a nice quote from Wynton Marsalis that I love, which is, he says, "A beat is a moment in the life of a groove. It's all about the time." And I can tell you something, as a person who's kind of not a pro at this, what these people do with such grace, is that it's all the work is in the time. And I think I'll be working on it until I die. But there it is. All right, so I wanted to say one other thing before moving on. Oh, yeah. So let me just sort of wrap up this little time section. So I've told you that time in the brain works as anticipation. We feel time in an intentional, a kind of by now sense. We don't have a little clock. We have dynamics in the brain that say, by now such and such should have happened. Oops, it didn't happen yet. This is slower time. And if you ask me, the first thing an animal learns, including us, about the environment is the temporal structure. In fact, I didn't show you this, but you can take that same cell and have a new environment where that 1 second, which never occurred, is now the main time things occur. And that cell completely changes the way it responds, okay? So these neurons are anticipating. And now I want to make a little bit deeper point and try to connect it to aesthetics. Okay, so it is the kind of prediction, tension, resolution. It's the kind of thing that occurs when there is an implied communication about how things will resolve. So that implied communication to another that has a mind like ours, at least we think they do, we think that we're dealing with someone else, now can respond to the time. I'm playing with you with these long pauses. We can respond to the time, and we can respond to other things. We can respond to the way things move, the way I showed you before. So there's a prediction, it was resolved. We can respond to the tension and release when someone teases us a bit, gives us a sense that they're coming back to the original key, but takes us on a little trip beforehand. And when you listen to especially my colleagues here, when you listen to them improvising, you'll hear that. You'll hear them taking you on rides that are not going to the expected note. And you're I lose my breath when I hear them. And I think that, we'll go back to Chris's point about play, is that it incorporates this sense of playing, this sense of exploration. I think sometimes, and you guys correct me if I'm wrong, you surprise yourself when you're improvising, yeah? Now I'll put the drummer on the spot here, if you don't mind. And so I think there's a sense in which we can play with tension and release. We can play imbuing someone else's mind with a sense of expectation of where they're going. And we can play pretty out there things if, in a sense, there's some kind of hook to come back to. A home for Odysseus after visiting the islands, okay? A relaxation to gravity from the dancer. But in the time, it's all about the time in the music. The time, the groove is there, and that means there's always sort of a home to come back to, even when things are, from maybe for some of you, out there, and for others, happy birthday, it's too boring, whatever. So I think that's an important point. And I think even this is where I want to ask you a question, if you don't mind, which is that I sort of sense that swing and playing around with eighth note feel and things like that, then in a way, that's already a bit of a tension and release even within the groove.
Yeah, absolutely. That's what makes the groove feel good and kind of abnormal, but great at the same time. For the most part, African music is like based in 6/8 time and 4/4, 2 times going against each other, but somehow sounds right. I'll see if I can kind of demonstrate that. This might be a good one. So Art Blakey, the jazz drummer, was famous for doing this. So I'm going to start. This is going to be in 4/4 time. This is going to be against it, and same with the left hand as well. Check it out. The tension's all, it sounded not together, but then together, and then it all will come in at one. So that's just a small example of something you could do with that.
So glad I asked. Chris, you have anything you want to add to this?
Yeah, I think I can help with this clap thing.
Is penicillin?
MD jokes. So part about this time and the expectation of time is something that musicians play with all the time. And it's a way that we can bring you and compel you to listen to us because you don't quite know what's going to happen. Next. And so just that evokes an emotional response. And so, but the only way that that can happen is that we have to be so in tune with one another and listening very deeply in order to be able to have that effect. And also you need to be listening deeper. The deeper you listen to, the more you can gain from that, from the music. It's like, you walk down the street and you see a friend you haven't seen for a while, and you say hi, and they say hi back, and then you ask one of the most dangerous questions in the entire universe. How you doing? And typically people just say, fine, and you say fine, and you move on. Sometimes people say terrible, and those people that always say terrible to that question, eventually you just say hi, and you walk the other way. But every once in a while you walk, and you say, how you doing? And they look at you, and they say, this is the most amazing day of my life. And immediately you're captivated, because it's a surprise. And we thrive off that as human beings. But the only way this works is if we can be completely in tune with one another. So we're going to do an exercise. And I guarantee you're all going to be amazing clappers after this. So I'm going to give you a set of instructions, and you're going to have to practice listening very carefully. As jazz musicians, we listen until we sweat. Now, listening is typically not an action that's associated with perspiration, but we're going to show you that it can be. I need your hands free. So if you have anything in your hands, like especially a smartphone, and you're tweeting about how wonderful this session is, cool, but just pause for a moment and then finish the tweet afterwards. I'm going to give you a set of instructions, but I don't want you to act on them until I tell you. So the first thing is I'm going to clap a rhythm. I want you to listen to it really carefully. And then I want you to join me and clap along. Go. I said clap with me. Yeah, now you got to groove with me. The goal of this exercise is to make it sound like there's only one person clapping in this room at a time. Which means now you need to be the drummer in this band. You need to be Charles. So there's a couple things you need to learn. In order to groove, you have to relax. Ooh. And you need to smile. Oh, did you hear that? Now you're starting to get there. Now, I'm going to stop clapping, but you're not allowed to stop clapping for this entire exercise. Everybody must continue to clap. Don't speed up, because this is a long exercise. It's going to be really hard if you do. Now, you can't lose this groove the whole time. But what I want you to do is turn to the person that's closest to you, not yet, and I want you to ask them what their lucky number is. Now, they're going to tell you what their lucky number is, and they're going to tell you a short anecdotal story from their childhood as why that is their lucky number. Fabrication is definitely a plus in this exercise. They must speak in complete sentences with proper grammar. They're going to tell you their story, and then they're going to ask you the same thing, what your lucky number is, and you're going to tell them that. All the while, not losing this groove. Good luck. Go. All right, keep clapping. Some of you have very amazing imaginations and connections to numbers, and some of you have very traumatic childhood experience with numbers, I can hear. Now close your eyes and listen. Now you're grooving. Now stop and turn to the person that you were talking to and look deeply into their eyes. And what do you see? I can see some couples haven't spent time doing this for a long time. Okay, stop. It's enough. What I see is an aliveness and an awakeness and a glistening that wasn't there just 3 minutes ago. Why is that? Well, I asked you to do the impossible. I asked you to listen to the instructions from me. I asked you to align your body with everybody else in this room, and it's a large room. It's a really difficult task. And I asked you to improvise. I assume you didn't have that lucky number story prepared and rehearsed before with the person sitting next to you. And you had to interact. There was no possibility of you being successful at this groove if you were anywhere else but here. If you were thinking about anything else in your lives that had nothing to do with the task at hand, you would have failed miserably in that clapping. We asked you to be nowhere else but here and completely present. And this is something that's so very, very important. These are the times in our lives when we reach our full creative potential, when we're nowhere else but here, completely deeply engaged. Psychologists say achieving a state of flow where you just lose track of time. There's the glistening there too, because I asked you to do kind of a silly exercise that was fun. It was play. And when you first started clapping with Mike, I was extremely worried. And then when you first started clapping in this exercise, I got more worried. But at the end, everybody was grooving. Could you hear how much better you could have aligned yourselves? The entire room was aligned and became hip and grooving in time. Why? Because then you were fully present with one another and you were here. You were listening deeply. And this is really an essential component to the manipulation of time for what we do as an art form, but also it represents, when you are in that state, the happiest and most productive moments in your lives. It's one of the reasons why I think jazz is the key to world peace. If we can all just achieve that state more often in our lives, we can go so much farther, and as a group together, go way farther. And I think this is something that we as jazz musicians, that's the state that we must be in every time we play music. And that's why we can do and create something spontaneously right before your very eyes if we're all fully present and listening until we sweat. We're going to do another exercise for you. We're going to play a song, and what we want you to listen like you just did when you did that exercise. Hear what you might have been missing from the first time that we played. Listen deeply and see what has been right before your very eyes that you've been missing.
Can I say one other thing?
What's that?
Who we're featuring on this tune, yeah?
Yeah, we're going to feature Helen's song on the piano.
All right.
Yeah. So.
Yes.
Thank you.
Can I stop doing neuroscience and just play with you guys again? Oh my God. Can we just hear it for the band again? I don't know what the right word is for that, but oof. So I don't know if you know that, it's the Thelonious Monk tune, Around Midnight. It's got to be one of the most beautiful and complicated tunes in the sense that no one, is there much agreement on what the B section really is, or is it?
Well, you know, Miles Davis is so influential, he played it differently than Monk did. And I think Monk also had different variations over the, you know, he played this tune over the course of his whole life. And he has a right to change it as he sees fit, I think. But I just want to return to briefly the idea of being in the moment. You know, I started as a classical musician, and not that classical music is not about being in the moment, but for me it was a very different experience because I would say 99% of your attention and energy was focused on interpreting the score as faithfully, as musically, as perfectly as possible on the stage. And I think Kenny Barron, one of the great jazz pianists, living hero, one of mine definitely, he said for him the difference between classical and jazz is with classical you didn't dare step on the stage until you had perfected it in the classroom, the music you were going to play. Whereas jazz is something you step onto the stage to perfect. And that's something I think I'm going to grapple with for the rest of, you know, however long I can play this music, because, you know, being a perfectionist, I don't like that feeling of just vulnerability and, right, kind of a loss of control maybe, and also the fact that in classical piano, it's a very solitary art form, but jazz, it's played with other people who see the world differently, hear the music, feel differently than you, and finding the place together in the moment, like that brilliant exercise Chris had you guys do. You know, I'm learning to embrace that, as it's terrifying and fun and amazing all at the same time. And Mike had asked, you know, when you improvise, you sometimes surprise yourself. I would say it's like I end up in places I didn't expect to. And it's like, oh, how do I get out of this? So, you know, here's to being in the moment.
All right. We don't have that much time, so maybe I did promise to talk about decisions. Should we do a little of that? Yeah, let's make a decision. I'll make a decision. I'll give you a little brief hit on decisions and just tell you why you're rational in the end. It seems like so counter to this being in the moment, but I don't really think that's true. So let me see if I can get my own back to my brain and away from whatever other organs were working there. Okay, so all right. So I'm going to tell you how the brain reasons. Okay, and it's how it reasons from evidence. And again, it's going to be the same trick of neurons in the brain that don't have to cause you to act immediately or don't cause you to have to worry about what's on front of your eyes or in front of your ears in that moment, but actually entertain a thought about it. And I'm going to try and show you fairly quickly what a thought is in the brain, in fact, a rational thought. So here's a problem. I ask you, or I can ask a monkey, you'll see why in a moment, we work with such clever animals, to decide between green and red. And when you do that, I'm going to show you a series of shapes. In this experiment, just 4 shapes, but they're chosen from this set of 10. And you see these over here favor green, and these over here favor red. You don't have to memorize them. I'm not going to test you on it. So, and not only that, this one, this semicircle, is the most reliable in favor of red. This urn is the least. This diamond is the most reliable for green. The Pac-Man, the least. So there's all these different levels of evidence, and you got a reason from them. It's kind of like predicting the weather. Lots of different information comes to you, some more reliable than others, and you got to come up with a prediction. Or like making forecasts about the news. Some reliable, New York Times maybe. Some unreliable, Fox News, ignore it. So here's what a single trial would look like. You'd see these 4 shapes. They came in some order. The first one was a pentagon. It was weak evidence for red. Then that was followed by this triangle, weak evidence for green. I think then this one came, this Pac-Man, more evidence for green, and then even more evidence for green. And the idea is this stuff is happening over time, half a second, half a second, half a second. And your brain is, if you were trained on this and you became knowledgeable about what these shapes were, then maybe you would add up the information in some clever way. So I'm going to show you that the brain does that by playing you again the electrical discharge from a neuron. This happens to be a neuron that cares about this place in space where the red target happens to be. Okay, so in our mind we're thinking, if this neuron is doing what I told you before, it's just telling you that he's planning an eye movement to the red and not to the green. But now we're going to look at how that happens. How does that decision unfold in time? Okay, so here we go. I'll play you a couple movies of this. Okay, so you remember that the neuron really likes this location in space. The shapes initially favored that, and then it went against it. And this is the cumulative evidence building up in favor of green, so against red. And you heard that neuron start to discharge when that pentagon came, and then gradually lost steam, a decrescendo, you might say, in the musical parlance. Okay, let's listen to another trial. So that was the opposite pattern. Okay, initially, this Pac-Man favored the green target out here. The neuron really likes this place in space, and there was gradually mounting evidence for that place in space, and that's associated with a crescendo in the firing, an increase in the rate of that neuron. And it was gradual. It's not just jumping to some level, it's gradually building up in time, building up a belief. This one's even the most interesting, I think, because here the evidence is sort of bouncing around between favoring this target, which is what the neuron likes, and then going against it, which is what the neuron doesn't like. And then the last shape, this diamond, gave more evidence for green, and that's what the neuron liked, and that's what the choice was. Now, if I showed you thousands and thousands of these trials, I would convince you that what the brain is doing is not just adding and subtracting numbers, incrementing and decrementing, but actually calculating the running sum of positive and negative numbers. And those positive and negative numbers, it just so happens, have a relationship to probabilities. For those of you that had some math in your life, a ratio of probabilities, and then the logarithm of that. Okay, who knew? All right, so it turns out, though, that that is the optimal way of making a decision from a sequence of samples of evidence. In fact, it's how Alan Turing broke the Enigma code in World War II. It was a big step in that code breaking, was intercepting messages and figuring out whether they might have been produced by the same type of machine. Okay, well, that I think is all I'm going to say about that. I mean, I could go on and explain how consciousness works, but I think we won't do that. I think I could. It would really not take long, but we have more important things to do. And I think the most important thing, oh, it's 8 o'clock already. Is that? So what's the deal here? All right. Well, I think, why don't we do this? Why don't we play a final tune out, and then you can just catch us and ask questions afterwards if you like, okay? And so with that...
So with all this decision making, we've decided that we're going to play a song that I think encompasses a lot about communication and about clarity and that too, with that groove. And in that tempo, we're going to play a song that was written not too far from here. It really encapsulates the spirit and the importance of Harlem in jazz history. It was written for the Duke Ellington Orchestra, one of the most popular bands in the 1930s at the time. And Duke Ellington was very much interested in thinking much larger than just Harlem, much larger than just the United States, but really thinking globally and the potential that this music has to bring diverse cultures together. And bringing diverse cultures together as a way of creating beauty and not ugliness, which often times happens when we're speaking across culturally. And he hired a Puerto Rican trombone player, the first Puerto Rican to be hired full-time in a black band in New York City. That was Juan Tizol. And Juan Tizol wrote this song for Ellington with kind of the inspiration of the jazz that was happening in Harlem, but also the inspiration of what was happening in his neighborhood, Spanish Harlem. And so he incorporated Puerto Rican and Latin grooves into this, but then it was also inspired by travel to faraway places, especially to the Middle East and Arab countries, and incorporated Arab melodies. And they called this Caravan. Hope you enjoy.
Charles. Hello. 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 Charles Miller on the drum. Ugana Kegwa on the bass. Jason Marshall on the saxophone. Helen Song on the piano. Mike Shadlen on the guitar. Thank you so much. Good night.
Thank you very much. Look, art celebrates the brain's cognitive capacities, and nowhere is this more on display than in jazz, and nowhere is jazz more celebrated than in Harlem, New York. Now, Harlem is not where jazz was invented, but it's where it is continuing to be perfected and advanced. So thank you all for coming.